Hey everybody, it's part 3 of solutions. We're going to look today into the stoichiometric calculations. At the end of this, we'll talk about what you've got in Moodle to be working on. There's a few more assignments, but we'll talk more about that at the end. So in this video, we're going to talk about how to use molarity in these stoichiometric calculations. All right, so here we go. You have to remember as we go through this, what is it that molarity tells us? Molarity is a term that means something. It means it's the number of moles of solute per liter of solution. If you don't have moles and you don't have liters, you do not have molarity. Okay. If we do know moles and we know what the identity of the solute is, then we can use that information to figure out how many grams we have in our solution. So this is where it becomes a little more complicated. If you know the molarity and you know the volume, you know how many moles are inside that solution, which means you know how many grams are in that solution. It just takes a little bit of mathematical work. All right. So here's a sample problem that we need to work out. It says how many grams of magnesium nitrate, which is a chemical formula of MgNO32, is found in 125 milliliters of a 0.45 molar solution. So in order to solve this, what do we know? All right, you have to look back. You can go back and forth if you want. They give you molarity and they give you volume. All right, we know the volume of our solution and we know the molarity. So what is the molarity again? I love when I accidentally click that button. Molarity is moles per liter. To find the moles and convert to grams, you use molarity. Remember the song from the really bad video, molarity, molarity is moles per liter of solution. So we're going to have to substitute numbers in place of these variables. All right. So the 0.45 is the molarity, X is the number of moles, and 0.125 liters. Remember the volume was 125 milliliters. So in order to solve for moles, we get to do some algebra. We're going to multiply both sides by 0.125 liters, and that looks like this. So when you multiply 0.125 times 0.45, you get out a calculator. Feel free to do that. What's the number of moles? All right, so we got 0.05625 moles is what my calculator says. But that's not what the question asked us for, all right? The question was asking us for grams of this substance. So we need to multiply that number by the molar mass. The molar mass of magnesium nitrate is 148.33 grams per mole, so it's 8.34 grams. All right, there's your final answer. That is using a solution to figure out how much stuff is in it. This was the second verse of that video. All right, so now here's another little thing to look at. How can we use this information in a reaction? So we need to know how many moles we have in a substance so that when it begins to do chemical reactions, we can go back and do stoichiometry. For many of you, this is not a good thing. You're like, oh my gosh, more stoichiometry. Yeah, I understand. It's going to be rough. Okay. So here's the problem. When aqueous sodium chloride is added to a solution of silver nitrate, silver chloride is precipitated out. How many grams of silver chloride should be precipitated out? That's the solid, that's the insoluble part. When 25 milliliters of a 0.1 molar salt sodium chloride solution is added to 25 milliliters of 0.1 molar silver nitrate. So again, there's a lot of words. That's a lot of stuff. Some of you are going to need to stop and write that down for a minute because that information becomes very, very important to us. So as we move on, we're going to work through this and see what we need to do. All right. First thing we're going to need is we need a balanced equation. So I'll help you with that. The balanced equation is that sodium chloride, which is salt, is being reacted with silver nitrate. Those are two aqueous solutions. It's going to form a solid called silver chloride. And then there's other stuff that's still dissolved in the water. That's the sodium nitrate. All right, so this is already balanced. Everything's a 1-to-1 ratio. It's already balanced. All right. So the other thing is we had 25 milliliters and 1 molar of both of the solutions. I tried to color code them here for you. So you have the 25 milliliters of 0.1 molar salt solution and 25 milliliters of 0.1 molar silver nitrate solution. So what we know is that this is a perfect stoichiometric ratio because the volume and the molarity are the same. That means that you're going to have the same number of moles of both of those substances that are going to be reacting. So if it's a perfect stoichiometric ratio, that's also how many moles of product will be made. Equal moles of each solution are being mixed. So since it's balanced, here's what's going to happen. You're going to get 2.5 times 10 to the third moles of each reactant. Okay? That means that when they react, it's going to make 2.5 times 10 to the negative third moles of silver chloride. I got this value by multiplying the volume, 25 milliliters, times the molarity. And with it being in liters and molarity, that's the numbers that you're going to get. Again, that wasn't what was being asked. The question was not asking for moles of product. The question was asking for grams. So we need to convert that number of moles back to grams. So here's the moles that they gave us. This is the number of moles. We need to know its molar mass. So we need to look at a periodic table. You find that silver is 107.87. Chlorine is 35.45. Those add up to 143.32 grams per mole. So how do we convert that into grams? So we know the number of moles. We know the molar mass. We multiply those values. And when you multiply moles times molar mass, we get the number of grams. So our answer in this case was 0.358 grams of silver chloride. All of that going back over here. This is the reaction that we started with right here. Okay, sodium chloride, silver nitrate. I love when it does that to me. Silver chloride and sodium nitrate were the products. We're figuring out how much of this stuff we were getting. All right, so here we go. Here's that thing we just went through. So let's do one more with a little more meat. This one's got just different numbers. It's going to be just a little bit, it's still not hard yet. It's just knowing how to do them. So calcium carbonate is an insoluble substance. It's also known as chalk. When we mix 400 milliliters of 0.5 molar calcium nitrate with 600 milliliters of 0.5 molar lithium sulfate, how many grams of calcium carbonate will be precipitated? Again, we already have a balanced chemical equation, which helps. It's 1 to 1 in terms of the reactants. 1 calcium nitrate reacts with 1 lithium sulfate. That's these substances right here, the calcium nitrate and the lithium sulfate. So now, maybe, there's our reactants. The products, it's a double replacement reaction, are these. And then what we need to know is how much are we starting with. So the red is the calcium nitrate. We have 400 milliliters, which is 0.4 liters. We multiply that by the molarity, and that will give us 0.20 moles of calcium nitrate. That's how many moles of, let's see if I can get this to work again one of these days, how many moles of this we're beginning with. And I can't write with my mouse. Okay, that's how many moles that we're starting with. But what about the lithium sulfate? How many moles of that did we have? Well, it's 600 milliliters, so that's 0.6 liters, times 0.5 molarity, and we're going to get 0.30 moles of the lithium sulfate. So again, there's more of the lithium sulfate than there is of the calcium nitrate. That means the calcium nitrate is our limiting reactant. Okay? If that's our limiting reactant, what does that tell us? Well, in the balanced equation, for every one of these that we react, we make one of these. Okay? There's the same number of moles of product as the limiting reactant. So now we know that we're going to make 0.2 moles of calcium carbonate. Again, all of this is coming from aqueous solution. We're mixing two liquids together, and this is what's happening. Okay. So now as we continue, that was not the quantity we're looking for. They were not asking us to solve for the number of moles of calcium carbonate. We wanted to know how many grams. So again, we need to multiply this number of moles times its molar mass. The molar mass of calcium carbonate is 100.09. So you multiply and you get 20.0 grams will be produced. Okay. Throughout all of these problems, these were relatively simple. You need a balanced equation and you need to understand the number of moles is what's important. All we need to worry about is if molarity, volume times molarity is going to tell you moles. So in solution stoichiometry, instead of converting grams to moles or converting all those other things that we did back when we did stoichiometry, you just convert molarity and volume into moles to be able to see what happens in the chemical reaction. There are 3 more assignments on Moodle that are using all of the solutions we've talked about, including one of them being a quiz. All right. The quiz is called assignment number 4 or something like that, solutions number 4, Molarity quiz. You have a limited number of attempts on that, and so you'll need to work on that and get the best score that you can. It does have the adaptive mode, I believe. I'll double check to make sure it does. All right. I plan on tomorrow, Friday sometime, making a lab video and posting that as well. What we're going to do is I'm going to do all of the lab experiment on video and then kind of help you through how to fill out the data form on a lab, and then you'll have to answer some questions based on the data that we collect together. I will post both the lab report form as well as the video on both Moodle and Google Classroom. There'll be a link to the YouTube page where you can see them. All right. Hopefully, as we're starting to go through these, you're starting to get some understanding of molarity and of solutions. Again, the biggest thing here, like we've taken these first 2 weeks, and this 3rd week will be where we wrap up the solutions. We'll probably look at taking a test next week, and then we'll move on to the next set of material. We're doing the best we can with this stay-at-home order. I really, really want to see you guys. I wish that there was a way for us to get together into a classroom setting again, but it just isn't right now, and it looks like not for the rest of this year. The way it looks, maybe not even next year. Who knows? We'll see how that goes. Just know that I'm trying to do what I can to help you guys out through this material. If you need any help or you have any questions, you can send me an email. I'll be on Google Meet Tuesday morning again at 10 a.m. I'll send that information out through Google Classroom early Tuesday morning. And then if you need me on Fridays, I'm sitting in front of my computer. You can send me an email. You can do whatever you need to do to get a hold of me with that Google chat. If you think you need a Google Meet, I'll be able to start one of those up on Friday morning as well. Hope you guys are doing well. Take care.